Because we had to chop off so much of the graphs of sine, cosine, and tangent in order to produce inverse functions, there's going to be some trickiness involved about their domain when we go to actually evaluate inverse sine, cosine, and tangent. Let's look at some examples. So first, let's find inverse sine of -1. So remember, we're just looking for some angle theta whose sine is -1. And there's an angle, also theta has to be in the interval from -π/2 to +π/2, because that's the restricted domain of sine. So this is the range of inverse sine. And there is an angle in here that produces -1 as the output of sine, and that's -π/2. So inverse sine of -1 is -π/2. So no problem there, nothing tricky going on there. So now let's look at inverse sine of 2. So for here, we're looking for some angle theta whose sine is 2. But wait a second, there is no such angle. The range of sine is from -1 to +1. 2 never comes out of the function sine. Going to inverse sine, the way of saying that is that the domain of inverse sine is from -1 to 1. 2 isn't even in the domain of inverse sine, so there is no such thing as inverse sine of 2. So this is undefined. And this happened because the range of inverse sine is, the range of sine is so small, the domain of inverse sine is also quite small. So got to be careful about that. That happens for cosine as well, of course. For inverse tangent, its domain is actually all real numbers because the range of tangent is all real numbers. Okay, so that's one thing to be careful about with inverse trig functions. Some of them have pretty small domains. Let's look at a couple other examples. So let's find sine of inverse sine of -1/2. So inverse sine of -1/2. Remember, we're looking for some angle between -π/2 and +π/2 in a unit circle so that the y-coordinate is -1/2. And you might remember that there's a nice angle. There's a nice angle in between -π/2 and +π/2 that makes sine be what we want. And it's -π/6. That's the one we're looking for. And of course, when you take sine of -π/6, you get -1/2. You might have seen this coming because look, we have an inverse function inside of the regular function. And the inverse function is supposed to undo, or inverse sine is supposed to undo sine. And so shouldn't we just get back what we put inside? And in fact, we do, right? -1/2 is in the domain of inverse sine, and so sine and inverse sine just undo each other and you get -1/2, as you probably expected. All right, let's look at something similar one here, inverse sine of π/3. This one's a little different because the regular trig function is on the inside and the inverse trig function is on the outside. So let's just evaluate this from the inside out. So inverse sine of π/3, so that's one of the nice values. Sine of π/3 is √3/2. And inverse sine of π/3, so right, on inverse sine, we're looking for an angle from -π/2 to +π/2, and √3/2 is about 0.8, so up here somewhere. So we're looking for some angle like this. And, you know, √3/2, that's an output value for sine that we're familiar with. We know what angle produces that. It's π/3. And again, this probably doesn't surprise you because look, we have an inverse function and an original function composed here, one inside the other. So shouldn't you always just get the input that you started with? And in this case, that's true. π/3 is in the restricted domain of sine. Remember, sine and inverse sine are only inverses on the restricted domain of sine. But pi over 3 is in the restricted domain of sine. So yeah, it works just like you would expect. These two functions just undo each other and you get pi over 3. Okay, so let's look at a couple more examples. This one looks very similar. It's inverse sine of 2 pi over 3. We can evaluate this from the inside out. So inverse sine of, now we want sine of 2 pi over 3, and you might look at a unit circle, but I happen to remember this value. I hope you remember this value too. Sine of 2 pi over 3 is root 3 over 2. And inverse sine of root 3 over 2, well, that's one we just looked at in the last example. Inverse sine of root 3 over 2 is pi over 3. Okay, but wait a second. Look at what just happened. We had a function composed with its inverse function, its supposed inverse function. Shouldn't those two undo each other and just produce the input value that you started with? So, well, that didn't happen. Why is it that we got pi over 3 here instead of 2 pi over 3? Shouldn't the inverse sine and the sine just cancel and give us 2 pi over 3? Well, it's not quite so simple. This value right here, 2 pi over 3, is not in the restricted domain of sine. And remember, the restricted domain of sine is from minus pi over 2 to plus pi over 2. So sine and inverse sine are not guaranteed to be inverses if you are not between minus pi over 2 and plus pi over 2. Since 2 pi over 3 is not between minus pi over 2 and plus pi over 2, sine and inverse sine don't just undo each other. You have to be a little more careful and evaluate this step by step. So the upshot of this is, if you have a trig function inside of its inverse function like this, you have to be careful about whether your angle is in the restricted domain or not. If it's not in the restricted domain, you can't just cancel those functions. So let's see how that works for cosine and tangent. So here's an example with cosine. So let's find inverse cosine of 3 pi over 4. So before we just, without thinking, cross out the inverse cosine and the cosine because they supposedly cancel, let's check, is this angle, minus 3 pi over 4, in the restricted domain for cosine, which is from 0 to pi? No, it's not. So we can't just cross out the inverse cosine and cosine here. We have to evaluate this step by step. So let's do that using the most important diagram, because that's the only trick I know. So let's draw the angle minus 3 pi over 4. That angle is going to be right here. Okay. Cosine of that gives us this, if we're in a unit circle. Cosine of this angle gives us cosine of minus 3 pi over 4 is minus root 2 over 2. Okay, so now I'm evaluating this. So we want inverse cosine of, cosine minus 3 pi over 4 is minus root 2 over 2. And then to evaluate this inverse cosine, we need to find an angle in the top semicircle that produces this x-coordinate. And that angle is going to be like this. You can see it's exactly the same as the angle we started with, except instead of going clockwise, it's going counterclockwise. But since it's the same size, it's 3 pi over 4. So again, because the angle we started with, minus 3 pi over 4, was not in the restricted domain of cosine, we can't just cancel these functions. We have to work it out. And you see, we do not just get what we started with. All right, let's look at an example with tangent. Let's find inverse tangent of 5 pi over 6. So, as before, let's ask ourselves, is this angle that we're starting with, 5 pi over 6, in the restricted domain of tangent, which is from minus pi over 2 to pi over 2? So is 5 pi over 6 greater than pi over 2? Yeah, it is. So this angle, 5 pi over 6, is not in the restricted domain of tangent. It's too big. So we can't just cross out this tangent and inverse tangent. We have to work this out step by step. So let's draw most important diagram. The angle 5 pi over 6 is going to look something like that. Okay. And tangent is the slope of this terminal side. So here's the line that has that slope. Now we need an angle between minus pi over 2 and pi over 2 that produces something on this line. Well, you can see we aren't going to produce an angle that gets to the left-hand side of this line because we have to stick to the right-hand semicircle because the restricted domain of tangent is from minus pi over 2 to pi over 2. So we are going to go to the right-hand part of this line, and it gives us this little negative angle right here. Well, you can see this small green negative angle is the same size as the opposite angle here over here on the left, but this big green angle, that was the original angle, 5 pi over 6, and so this little green angle on the left is what's left over before you get to a half turn, and that's pi over 6. And the angle we want in here is just a negative version of that, so that's negative pi over 6. Okay, so writing this all out, inverse tangent of tangent 5 pi over 6, if we actually calculated that, that would give us minus 1 over root 3. That's the slope of that line. And then this diagram tells us that the angle on the right semicircle that would produce minus 1 over root 3 as its tangent is minus pi over 6. All right, so the upshot of all of this is if you are working with inverse trig functions, you have to be very careful about the domain, and in particular, the restricted domain of each of the trig functions.